The next part of 4.2, we're going to talk about some trig formulas, or another word for it is identities. So throughout this unit and the next ones, actually, you'll see this word. So we have formula, formulae, or identities is one you'll see a lot. Identities are really the same as a formula. It's just sort of special to trig. They call them identities. All right, so the first one I want to mention comes from the concept of even and odd functions, which we discussed in a previous unit. And we talked about how this relates to the graph. So when we get to graphing trig functions, this will maybe make a little bit more sense, but you can also use the unit circle to identify this. So I want to we'll just go ahead and write this down. If you have cosine of a negative angle, that's the exact same value as cosine of its positive angle. If you have sine of a negative angle, this is just negative sine of its positive. And if you had tangent of a negative, it actually works out the same as sine. So for example, if I wanted to figure out, let's say, what is cosine of negative 3 pi over 4. If we take a look at the unit circle, so I did reference this in the previous video but didn't really show you. So here's the complete unit circle. Notice that negative 3 pi over 4 is not actually on here, but positive 3 pi over 4 is. So what we can say is, well, this is actually the same as cosine of positive 3 pi over 4. Let's go ahead and take a look at our unit circle. Identify where that is. I can't mark on this, but you can hopefully identify where the 3 pi over 4 is. And we want the x value, so that ends up being negative square root of 2 over 2. And that would be my final answer. Or we might say something like, what is sine of theta? So I'm not giving you the angle this time, but what is sine of theta if sine of negative theta is 0.67? This is not really a unit circle question, but you can still identify it because sine of negative theta equals negative sine of theta. And so this just tells you that sine of theta will be negative 0.67. And we'd be all set with that problem. Okay, so those are the even and odd functions. The next type of formula I want to talk about is periodic behavior, basically. These aren't really formulas. But what I want to point out here is if you're on a unit circle, let's say we're over here at pi over 6, if you rotate around the circle by 2 pi and you end up at a coterminal angle, you're at the exact same spot. So what that tells me is that sine of any angle is equal to that angle plus or minus 2 pi, right? So even though the angle has changed, the sine value has not, because you're still really in the exact same spot on the unit circle. And this is true for all of the trig functions, including the reciprocal ones, and cosine and tangent. So I won't put the reciprocals down, but know that it is true for those as well. So a typical question for this might be something along the lines of, let's say evaluate, let's do 2 examples here. The first one is cosine of 13 pi over 6. Now notice 13 pi over 6 is not on here. We actually stop at 11 pi over 6, all the way on the other side of the unit circle. So rather than dealing with 13 pi over 6, let's find a coterminal angle. And let's do 13 pi over 6. And since it's too large of an angle, let's just go ahead and subtract a full rotation. And so this is part of the reason we did this in the last unit, minus 12 pi over 6. And so I actually end up with 1 pi over 6. So now what I could say is that cosine of 13 pi over 6 is actually equivalent to cosine of pi over 6. And now this is a value I could find on my unit circle. Take a look at pi over 6. Cosine is the x. So one way you can show your work in these problems is to just sort of draw this really quick. And then you know that cosine is the x value, and so that would be my final answer. Alternatively, we might have something like, let's go with a negative maybe. Let's say I wanted cosecant of negative 3 pi over 4. Now there's actually two ways to do this one. We already talked about the positive and negatives, but I'm going to do this using coterminal angles. So negative 3 pi over 4 is not actually on the unit circle. So what I'm going to do is add 2 pi to this. And so I end up with, I end up with 5 pi over 4. And so what I need to do now is evaluate cosecant of 5 pi over 4. So we do a quick check of our unit circle, find 5 pi over 4. It's root 2 over 2, but they're both negative. Cosecant is the reciprocal of sine, don't forget. So this was 1 over sine of theta. And sine is the y value, so what I have to do is I have to take this and actually flip it. So I'd end up with negative 2 over root 2. But we don't like having radicals in the denominator, so I'm going to go ahead and multiply that by root 2 over 2. And I end up with just negative square root of 2. And that would be my final answer. Okay, the final trig identity is actually my favorite. Even when we start getting new ones, this is my all-time favorite trig identity. And it's called the Pythagorean identity. Basically, the idea here is if you're anywhere on the unit circle, so let me just sort of sketch a rough circle. So let's say I have this point, xy. Notice that I could make a triangle, a right triangle here with y and x and a radius of 1, or a hypotenuse of 1 because the radius is 1. And so then that tells me that x squared plus y squared equals 1 squared based on the Pythagorean theorem. And this is true no matter where I go, right? So if I have a 1 and then this is now my y and this is my x, not y again. The same thing is true because of the Pythagorean theorem. But remember, x and y are actually sine and cosine, so what we're really saying here is cosine of theta squared plus sine of theta squared is always equal to 1. For any possible angle you give me, this is going to be true. We can actually show this, on Desmos. So if I do, I need my functions. I need cosine of, I'm just going to use some random letter. So I can add a slider for it. Then let's go ahead and go back here. Okay, squared plus, let's do sine of a, boom, boom, squared. And then for any angle from, let's go from, well, we can even go negative, I guess. Negative 35. 0.1, sure, why not? Okay, so I'm going to take this and I'm just going to keep sliding it along. So A is changing, right? To prove it's changing, I could do something like, let's just see what sine of A is. And then we'll also do cosine. So notice A is actually changing. You can see that there, but it's always equal to 1 when I have cosine of a squared plus sine of a squared, no matter what value that is. So that was always super cool to me, that it always just comes out to equal 1. Something that looks kind of complicated is just always equal to 1. I thought that was pretty awesome. Now, this is not correct notationally. What you will always see is actually cosine squared of theta plus sine squared of theta equals 1. But these are exactly identical. Just know that this is what you'll see if you ever try to look this up. But those are identical equations. So now if I had a problem, I might say something like, typical question would be, determine cosine of theta if sine of theta equals 0.3. And then I'm also going to say, and I also know that tangent of theta is negative. So you start off by using this first bit of information here. You'd say, well, I know cosine squared of theta plus sine squared of theta equals 1. So therefore, cosine squared of theta equals 1 minus 0.3 squared. So you get out your calculator. You say 1 minus 0.3 squared. We get 0.91. And now I have to take the square root, 0.91. And so I get this sort of 0.95, whatever. So we end up with, cosine of theta equals plus or minus. Now I took the square root of both sides, so I'm worried about that plus or minus. Now since tangent is negative and sine is positive, remember that's in this quadrant, sine is positive in quadrant 2. So since I'm in quadrant 2, that actually means I want the negative, so my final answer would be cosine of theta equals negative square root of 0.91. And I would probably just leave it in that format, even though it kind of looks messy. You could round it if you want. We might say round to 3 decimal places. I don't remember exactly what it was, 954, we'll say. But that would be my final answer in this case. So once again, I used the Pythagorean identity first, Pythagorean identity, which solved for cosine, but I have that plus or minus. So then I use this other piece of information to determine that I actually wanted the negative value, and that's where I got that negative sign from. And that would be my final answer. Okay, and that concludes section 4.2. We've now seen everything there is to see for section